As we just saw in 8.1, the purpose to completing the square is to solve a quadratic equation. Remember, quadratic means it has an x squared term as its highest power. So the idea behind completing the square, to complete the square, we write our equation in the form x squared plus bx equals c. Find the value of, we took our middle term, divided by 2 and squared, and add it to both sides, then factor. This sets us up to use the square root property to solve for x. If we wanted to solve an equation in our standard form of a quadratic, we need to factor it. But since we only have variables a, b, and c, we can do it by completing the square following the same steps that we did last class. Okay, I'm going to show you how to complete the square on this polynomial on a separate page. This is not something I expect you to be able to do right now. You have all of the tools you need, but because it has so many variables that we're going to be dividing, this isn't something I would expect you to be able to do on a test. So I'll show you on a separate piece of paper. We start with ax squared plus bx plus c equals 0. We want to set it up into the form where we can complete the square. So subtract c from both sides. Ax squared plus bx equals negative c. Divide everything by a. So you should recognize these steps from the videos you just watched. X squared plus b over ax equals negative c over a. Now this is the number that we want to complete the square on. So we have b over a divided by 2. Well, if I have a fraction divided by 2, b over a divided by 2 is the same as times 1/2. So this is b over 2a. And then we square it, b over 2a squared. And we'll leave it in that form. You can write it as b squared over 4a squared, but we'll leave it as b over 2a squared and see if we can maybe simplify it later. So I'm going to add to both sides b over 2a squared plus b over 2a squared. So now I have x squared plus b over ax plus b over 2a squared equals, and this is where squaring it will help us, negative c over a plus b squared over 4a. I need a common denominator, so I'm going to multiply the first fraction by 4 over 4. And I'm going to factor our perfect square trinomial. So again, the same steps that we saw in the last section, however, now we're doing it with variables. So we have x plus b over 2a squared equals, now I have b squared minus 4c. B squared minus, this is squared actually, so we want another factor of a. This should start to look familiar soon. So b squared minus 4ac divided by 4a squared. Applying the square root property, I take the square root of both sides, plus or minus. X plus b over 2a equals, now I know the square root of 4a squared, so we'll leave this plus or minus the square root of b squared minus 4ac divided by 2a. One more step, I want to subtract b over 2a from both sides. X equals, they already have a common denominator. Let me pull it down a little bit more. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now this equation right here should sound familiar because that is the quadratic formula, and this is one that you absolutely have to memorize. There are some songs and some little chants that you can use to remember it, or stories. So if you need some help remembering the quadratic formula, talk in your table group to see if anyone has some tips for you, and we'll talk about some next class as well. So let's look back at the notes packet. I'm going to take this away. And we have the quadratic formula here as well. And what we want to do is apply this to an equation. And notice now instead of variables, I have numbers. So we need to know, what are these numbers? Well, the one with the x squared is our a value, with just the x is our b value, and no x is our c value. So alphabetical order in descending order. And we're going to substitute these in. So x equals negative b. And remember, whenever we substitute, put parentheses. That way we're not accidentally forgetting negatives or anything like that. Plus or minus the square root of b squared minus 4ac all over 2a. So just substituting in those values. At this point, you might want to start looking at doing some of these calculations on your calculator, because some of them do end up being big numbers. So negative 16 plus or minus the square root of 256 minus 60 divided by 6, not too bad, equals negative 16 plus or minus the square root of 196 divided by 6. Square root of 196 is 14, so that's nice. Negative 16 plus or minus 14 over 6. So this is actually our two answers. Negative 16 plus 14 over 6. Negative 16 minus 14 over 6. I can simplify even further. Negative 16 plus 14 is negative 2 over 6, which is negative 1/3. Negative 16 minus 14 is negative 30 over 6, which is negative 5. So I have two values for x, negative 5 and negative 1/3. The quadratic formula should always give you two answers unless the square root has a radicand of 0. Let's look at another example. Our first step when we're looking at this, does it factor? No. Could I complete the square? Sure. But what I want to do is I want to practice using the quadratic formula. So let's identify our a, b, and c. Now, in order to use the quadratic formula on this, it has to be in standard form, meaning it has to be set equal to 0. So we need to subtract 3 from both sides. 2x squared minus 4x minus 3 equals 0. And then our first one is a, second is b, and third is c. So a is 2, b is negative 4, c is negative 3. And then we substitute into our quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So notice I said the quadratic formula, and as I was substituting, I replaced within parentheses each value of a, b, and c. Negative of a negative makes that a positive, so we get 4 plus or minus negative 4 squared is 16 minus, and then it's going to be negative 6 times 4, so it becomes plus 24 divided by 4. So we get 4 plus or minus the square root of 40 over 4. Now be careful, because this is inside of a radical, so we cannot divide the 40 by 4. What we can do is 4 over 4 plus or minus the square root of 40 over 4, which gives us 1 plus or minus, and then we want to factor this. So this is 4 times 10. The 4 can simplify out. 2 times the square root of 10 over 4, which does reduce to 1 plus or minus the square root of 10 over 2. I have two answers here, so I put set brackets so that we can see that there are two answers there. Go ahead and try this, pause the video, do it with your group if you've got questions, and then when you're ready to resume, we'll try example 3. Okay, if you finish to try this, think about this concept check. We want to find our values of A, B, and C, and just like in the last example, we have to do something first. In order to find our values of A, B, and C, we need this to be in standard form. So we need to subtract 7 from both sides. So we have x squared minus 7 equals 0. But notice here we have a missing term. So we can add the placeholder 0x. And what that does is it lets us see where our A, B, and C values are. So our A value here should be 1, B is 0, and C is negative 7. Let's look at example 3. In example 3, we have fractions, and if we don't need to use fractions, we don't like to have them. Therefore, we can clear these fractions. Just like we did in chapter 6 and in chapter 7, the way to clear the fractions, because this is an equation, I can multiply both sides of the equation by the same value. And so I want to find the LCD, which is 2, and multiply that to every term. And when I multiply everything by my LCD, that should leave us with an answer that has no fractions. So we have m squared minus 2m plus 1 equals 2 times 0 is 0. This is what's called an equivalent equation, meaning it will have the same solutions. Now we can factor this, or we can try to factor this. We can try completing the square, or we can try quadratic formula, and we should try them in that order. If it's easy to factor, factor it. If it's easy to complete the square, do that. Otherwise, use the quadratic formula. So looking at this, I say, oh, this looks like it might be a perfect square trinomial. So let's try m minus 2 divided by 2 is 1 squared. Will that give us this trinomial? M squared minus 2m plus 1. So we didn't even need the quadratic formula on this. Take the square root property. Notice I have the square root of 0. Well, what number times itself is 0 is 0. And positive and negative 0 are the same thing. So we have m minus 1 equals 0. Plus 1, m equals 1. I'd like to show you how this would look if we had used the quadratic formula. A is 1, B is negative 2, and C is 1. So we get x equals the negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative and negative, again, is positive 2 plus or minus the square root of 4 minus 4 over 2. Well, 4 minus 4 is 0, so this is 2 plus or minus the square root of 0 over 2. And just like we were mentioning, the square root of 0 is 0, and whether I add or subtract 0 to something, it doesn't change. So this is 2 over 2, which is 1. So this is the example of a case where we will have only one real solution. Let's go ahead and look at example 4. All right, in example 4, again, we have our terms out of order, but we don't have any fractions here. So what we need to do is put this into standard form. It's nice when our leading term is positive, so let's move everything over to the left-hand side. Plus 3x squared plus 3. So we have 3x squared plus x plus 3 equals 0. So then a is 3, b is 1, and c is 3. Into the quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, substituting into parentheses. So we have negative 1 plus or minus the square root of 1 minus 6 times 4 is 24 divided by 6. which gives us negative 1 plus or minus the square root of negative 23 over 6. Negative inside of a radical tells me this is going to be a complex non-real number. So I can write this as negative 1/6 plus or minus the square root of 23 over 6i. Square root of 23 doesn't simplify, so that will be our answer. Notice how this is two complex solutions. And they are complex because the inside of our radical was negative. Go ahead, pause the video and do the try this. When you've finished the try this, think about the concept check. What will be the first step for solving this problem? If you're not sure, go back and look at a couple of the examples from this chapter, or from this section. See what our first step was when solving this. What's the first question that we asked? And then let's go ahead and look at the next page. All right, once you finish the try this and the concept check, we want to look at what does it mean when we get these solutions. So sometimes we got two real solutions, sometimes one real solution, and sometimes two complex solutions. And the meaning behind those values that we're getting as our solutions, that is where our function equals 0, where all of our ax squared plus bx plus c is set equal to 0. And what that means is that our output, our y value, if we write it as a function notation, would be 0. And that's our x-intercepts. So that means if I were to graph that quadratic equation, it would be a parabola. And where the parabola crosses the x-axis are the solutions to the equation. Now, how many solutions will we have and what type of numbers will they be? Well, remember in the quadratic formula, we had that radical, and the radical is actually what determines how many solutions we will have and what type of solutions they will be. So remember when we had the thing inside the radicand, when it was negative inside of the radical, we had two complex solutions because we had plus or minus something with an I. When it was 0, we had plus or minus 0, which gave us one real solution. What that will look like is it will be a parabola that touches but does not cross the x-axis. One solution. And then what if that number is positive and not 0? Well, then we'll have two solutions and they will both be real because we won't have an I value. The square root of a positive number will be a real number. And it will be plus or minus that real number, so there will be two real solutions there. All right, our last example for the day, we want to look at how many solutions and what type of solutions do these equations have. Notice we don't want to find the solutions, we just want to know what they are, what type of numbers they are. So in order to do that, we're going to look at what's called the discriminant, that was the radicand, and inside of the radical is the b squared minus 4ac. So we're going to say a is 1, b is 2, c is 1. B squared minus 4ac, 4 minus 4 is 0. Now remember, if I had plus or minus the square root of 0, it gave me one real solution. And what that looks like is a parabola that just touches the x-axis but doesn't cross. So that would be the graph of A. For part B, we're going to do the same thing. We say A is 3, B is 0, and C is 2. We want B squared minus 4AC. So we have 0 squared minus 4 times 3 times 2, which gives us negative 24. This is negative, and if I had plus or minus the square root of negative 24, there would be an I involved. So this is two complex, non-real solutions. And lastly, part C, A is 2, B is negative 7, C is negative 4, B squared minus 4AC, negative 7 squared minus 4 times 2 times negative 4, 49 plus 16 times 2 is 32, which is 81. If I have plus or minus the square root of 81, that actually is plus or minus 9. If I have a number and I add 9, a number and subtract 9, that will give me 2 real solutions. 2 real solutions means 2 x-intercepts. 2 x-intercepts is graph C. And then 2 complex solutions. I don't have complex numbers on my x-axis, so that looks like a graph that does not cross the x-axis, which would be graph B. So I want you to try this. Try graphing it on your calculator and seeing if your answer makes sense, and then you can start working on the Math Excel.